Hello students. With in the present class we'll discuss about the different terminologies which are used in the aerial photogrammetry, different parts of the aerial photogrammetry and the scale of the photograph. Okay. So in the scale of the tilted photograph we'll be seeing with respect to the present class. In the previous classes we have discussed about different types photograph and how it has been done. Okay, the basic idea I have given, and in the present class we'll discuss more about the technical part, that is parts of the photograph and the scale of the photograph. So in the previous class we discussed about the different types of photograph, vertical photograph, tilted photograph, oblique photograph and all this. Now we'll go further and we'll understand what are the terminologies which are related to the inclined photograph, or we may say it's a tilted photograph with the help of tilted photograph. So these are the, I'll say these are the terminologies with respect to the tilted photo, with respect to the tilted photos. Okay, so in this the first important which we should understand is this area, uh, this area which is called as the perspective projection. This area is called as perspective projection, or this is nothing but your photograph. This is nothing but your photograph on which everything will get printed, everything will get printed. Now I'll say that my aircraft is at this location which is denoted as O, and I'll make a line, I'll make a line in which my aircraft is moving. Again the previous aircraft will repeat. This is my aircraft. Now it is something looking like fish again. Okay, this aircraft is moving. This line is called as flight line. A line along which the aircraft is moving is called as the flight line. And the position of the camera or the position of the lens is denoted as point O, okay, which is called as the the point of projection. It's called as a point of projection. Okay. Then there is one more concept. Imagine this is my, if I say this is my aircraft, here is my camera which is denoted as point O, then this entire height with help of MSL, mean sea level, with respect to the mean sea level is denoted as H, which is called as flying height, which is called as flying height. It's called as flying height. Okay, this is denoted as with capital H. Okay, this is denoted as capital H, which is called as flight height. Then there is another point which is important, called as focal length. Next point is called as focal length. The focal length is nothing but a distance which is measured again in centimeter. Every lens has got its own focal length. That is the distance between the point O till the point K. The point K is called as the principal point. The point K is called as the principal point. This is the, for a photograph, as I said, these are geo-referenced images. These are nothing but every photograph is geo-referenced. The meaning of geo-referenced is they have latitude as well as longitude. They have latitude as well as longitude. This latitude longitude are here denoted as x and y, denoted as x and y. So here this is my x, this is my negative y, sorry, this is my y, this is my x, this is my positive x. Okay, so as with respect to Cartesian coordinate system, this naming is given, and they meet at this point. This point is called as the principal point. This point is called as principal point, as denoted as the point K, the point of intersection on the prospective projection or a photograph where X and Y lines join is called as the point of K. This is called as a prospective, or the principal point is called as principal point. And the distance between this O to K, is denoted as F, which is nothing but the focal length, which is denoted as F, which is nothing but the focal length. Okay, then the next comes, there is one more point. Now this is my point O. If I drop a plumb line, here, I'll say this is my plumb line. Okay, this is my plumb line. Then this point will fall at this location. This point will fall at this location, which may be different from, if it is if it is exactly vertical. If it is exactly vertical photograph, then this point and the principal point is might be at the same, that might be at the center, but this is a tilted photograph, they are a bit tilted. Okay, they are not exactly horizontal. Imagine this is my point O. Now if I drop a exact perpendicular, then this will meet at this location. I'll denote it as a K. Okay, and in case if it is exactly vertical, what will happen? It will again drop at the same location. This will again drop at the same location. Okay, so in case of exactly tilted photograph, the point N, this is denoted as a point N, which is called as a nadir point. It's called as the nadir point, denoted as N, nadir point. If it is exactly vertical photograph, this K and N are at the same location. K and N at the same location because it is exactly vertical. But here what is happening? This is bit tilted photograph, because of which what will happen? My point O is over here, then the inclined or so-called principal point as this, and the plumb point, which is called as nadir point, is at the different location, which can be denoted at this location. Okay, this point is called as nadir point. Same way, this has been continued at the bottom, and this is fall on the ground, which is called as ground nadir point. When it's fall on the ground, it's called as ground nadir point. It's called as a ground nadir point, denoted as N. Same way, if this is my principal point, if I extend the same line, and when it falls in the ground, it's called as ground principal point. It's also called as ground principal point. So this is capital N is denoted as ground nadir point. This is denoted as ground principal point. Okay, so this is the three terminologies. Next point is, if I measure this angle, if I measure this angle, this is called as tilt of the photograph. This is called as tilt of the photograph. In case of vertical photograph, what will happen? There is no tilt, so there will not be any angle. There will not be any angle. But here they're forming an angle. The nadir point and the principal point is forming some angle. That angle is called as the tilt angle. This point is called as tilt angle. Okay, so denoted as the T. Denoted as T. When I denote that as a T, this is called as tilt angle. Sorry. Then there is one more line. There is one more line, or which joins. I'll take a different color. I'll take yellow, and I'll explain now. So now, if I join this, point, that forms a line. Here in this diagram which I had drawn here. I am joining these 2 points. This point is called as the principal line. This line is called as the principal line. While this plane, the plane which is being formed by angle O, or I'll denote, this plane, whichever is formed, this entire plane is formed, is called as the principal plane. This is a plane which is formed as the principal plane, and this line is called as principal line. This line is called as the principal line. Okay, then I'll just delete this so that you can clearly see. Then there is one more point. There is a line which bisects this angle ON and K. There is a line which is shown in the dotted form. There is a line which bisects the triangle ON and K, or I say it bisects the tilt angle in two equal halves. Okay, I'll denote that as T by 2. This T by 2 is called as isocenter. That falls over here, that falls on the point and denoted as I. That denoted as I is called as isocenter. I'll say I isocenter. I is the isocenter which bisects the tilt angle is called as isocenter. Okay, then there is one more point called as swing. There's one more point is called as swing. The swing is nothing but this angle which is measured from the point y or the x-axis is called as the swing. This is called as the swing. This talks about the shifting of the principal line, shifting of the principal points. Okay, so these are the terminologies which we use. In case of the vertical photo, the tilted photograph. Okay, so you understood the main points are the prospective projection, then comes the principal point, nadir point, ground principal point, nadir point, ground principal point. Okay, then this is the distance between O to K. This is called as the point of the lens, or this distance from O to K is denoted as F, is called as focal length. This is then the angle measured between ON and K is called as tilt angle T. Okay, so these are the few important points which you need to understand. This is again important question with respect to your exams also. Then let us have a look at a video which will talk about the similar points in a very deep manner.
This distance is nothing but a swath, for example. Okay, so let us say this is my camera assembly. Okay, so this is my flying height h, right. So this is my negative image plane, and this is my exposure center where all the rays from the terrain are going to meet and they are going to again diverge towards the image plane. So this is the optical axis here, shown here. Fine. So this is the focal length, as you know already from last lecture, right. So this is the way all the rays are converging to the perspective center, and again they are diverging to the image plane. So, and they are creating an impression on the sensor or the image plane, or we can say negative plane. Now, since negative and positives are no more a valid term, but still in the books these things are given, and still we are going to use these in order to distinguish between a negative plane, that is a sensor plane, or the image plane, which is a positive plane, which we really see, because as we know that negative plane image is an inverted image and that we cannot work with, and that is why we need a positive image. So, this is my positive image here, right, shown by here, and which is also located at a distance called focal length from perspective center. So, that is the overall idea you have, and you should develop this idea first. That means, what is the mechanism of data acquisition for a given one exposure of the frame camera. Okay. So, that is my swath, as I already told. Well, what about this distance? This is also called the swath, but swath along the flight direction. So, this is the swath, what we call swath is my swath across the flight direction, and generally we do not write across the flight direction, we rather only write the swath. So, this is called swath, the whole term. So, whenever you want to specify this swath which is along direction, you have to specify like that. Okay. So, now I can write that swath is equal to 2h tangent of theta x by 2, because the across the flight we have theta x is my field of view, total field of view. It is very simple relationship, you can find out.
Now we will see about the scale of the photos, which is an important part in case of the aerial photogrammetry or the vertical photographs. So we'll be talking about this scale in case of vertical photograph as well as the tilted photograph. So what do you mean by the scale? The scale is nothing but actually it's measured as the map distance divided by the ground distance. Map distance by the ground distance. So if uh, there is something, if I say 1 is to 10 as my scale, 1 is to 10 on the scale. So if 1 unit on the map is equals to 10 units on the ground, this is the meaning of 1 is to 10. This is called as a scale. Okay, so it can be a centimeter or meter or kilometer. I'll say 1 centimeter is equals to 10 kilometer. If I say, then this indicates that if I measure 1 centimeter distance on the map, then that will measure as 10 centimeter on the ground. This is the meaning of the scale of the photograph. Now let us see the first image where what I had done here is, for easiness I have already drawn the image. So this is my point O, this will be my point O. This is the perspective projection. This is, I'll denote it as K, principal point. Then here the actual image which has been captured, this is my ground level. This is my ground level. I'll say as GL, ground level. Okay. So this point, it is on the ground, is been presented here. Okay. So that point is coming at this location. I'll name this point as point A. On the ground, I'll name it as uh, the capital A, and here on the, this is the datum line, this is the datum line, so I'll that name as A naught here. Okay, and this is the datum line point, so here on the photograph I will name it as O naught. Okay, this point on the ground I'll name it as capital K, the ground I'll name it as capital K, while the distance OK, as we discussed in the scale photographs, this distance is nothing but the focal length denoted as f. Okay, while this distance is nothing but the height of the object. vertical height of the object, that is h, and this distance from O to datum, okay, this is denoted as h, which is nothing but the flying height, while this distance will become h minus small h minus small h. This will be the distance. Okay, now let us say what is the scale of the photograph. So already written map distance by the ground distance. In this case if I say my s is equals to map distance is the distance, just change the color so that you will understand in a better way. Okay, so this distance a to k, I'll name this is the map distance, so I'll name this as Ka divided by the ground distance, nothing but capital Ka. From the similar triangle, what I'll do is because I know the values of, I can easily get the values of focal length, height of the object, and this part. So I'll consider this triangle O. I'll consider this triangle O, K, and A for map distance. O, K, and A for the ground distance. So from a similar triangle, I'll plot this as OK divided by the, again this O capital K. Okay, so this, what is meant by O? This is OK is nothing but F, and this is nothing but your H minus H. So where F is nothing but focal length, then H is nothing but your height, flying height, my flying height, and this H is nothing but my height of the object. So if I know all these points, I'll be able to find out the scale of the photograph. I'll be able to find out the scale of the photograph. Now let us check, what if I have the 2 points instead of one. I have a 2 points. Well, we'll check in the next slide. Okay, now we'll see what will happen if we have 2 points. Okay, so let us consider 2 points. I'll say this is our prospective projection. This line is a prospective position. This is the point of flying height. Okay, and then I have 2 points. I'll name them as point A, and this will become my point B. Same way, when they plot over a prospective projection, they will become B small a and small a. Same way, the datum scale, I'll name this A naught. I'll name this principal point as K naught. This I'll name it as B naught. Okay, and this is my point K. This is the principal point, point K. With respect to that, this will become KB. This will become KA. This is nothing but the height of the object. Nothing but the height of the object. So the distance from here till here, this is my ground. This is again a ground. Okay, distance from this distance is denoted as h. Same way, say this distance is denoted, I'll say as h. I'll denote this as HA, height of the object A. Same way, this I'll denote as HB. This entire distance from the point, the lens point or the point O, till this is denoted as capital H. Now this distance from the O point till the height of the object will become H minus HA. Same way this will become HB, this will become HB, and this will become H minus HA. Now again I'll apply the same formula of scale. So the scale is equals to map distance divided by ground distance. So now we'll find out the scale for point A as well as for point B. Okay, so point A, when I consider this point A, when I consider here, the map distance is nothing but AK, and the ground distance will become AKA. Ground distance will become AK. Again, I will consider the so-called similar triangle formula. So AK will I can write down as OK, and AKA I can write down as AKA I can write down as OK. As we know, OK is nothing but F, and OKA, this distance, is nothing but H minus HA. Similarly, for point B also we'll try to find out what will be the distance. So map distance is nothing but here KB, I'll write down as BK, and the ground distance will become BKA. So again similar triangle formula I'll apply. Okay, I'll say this BK is as OK, and BKA is nothing but the O, so become BOKB. So again I can write down F minus H minus HB. So overall, from both of these I can understand that the scale of the photograph can be calculated as F minus H minus H, where F is nothing but the focal length, this H, capital H, is nothing but the flying height, and this Z is small h is nothing but the height of the object. Okay, so now this is the overall height. Now I can write down the scale for the datum also. Let us try what will be the datum scale. So here instead of K, I'll directly talking about a uh, I'll be directly talking about the datum. So I'll find out only for A. So the map distance AK, and the ground distance will be A naught K naught. So again I'll take a similar triangle OK divided by OK naught. OK is nothing but F, and OK naught will become h. So the datum scale, I'll write down as S datum, can be found out by f minus h, can be found out by f minus h. This formula we can use to find out the datum scale. Now imagine if you have the points like instead of only one a and b, I have a point like C, I have a point like D, I have E here, then F, G, H, I, J, something like that. I have too many points over here. But at this moment, I can't find out for every individual. Okay. Instead, what you can do is you can measure the heights of this A, B, C, D, F, G, H, I. Then you can find out the scale as average scale, that is f by h minus h average. This will become the scale of the photograph, that is average. Now what will you do if you have a map as well as the uh, the image? You have a map as well as image. At that case, you can find out the scale of the photograph as uh, scale is equals to map distance, sorry, photo scale divided by map scale. Same way, the photo distance divided by map distance. So remember these formulas. By this we'll be solving few of the problems. We'll be solving few of the problems in our next few classes. Okay. So this is with respect to the scale of the vertical photograph. I repeat here, this is with respect to the scale of vertical photograph. So if the question appears in exam, write down the scale of the vertical photograph, you have to write down both of this. Okay, so this is for the today. We'll end it here, and we'll take the scale of the inclined photograph in the next class. For more such videos on the advanced surveying subject, you can go to our YouTube channel. You can like this video, you can subscribe to our channel and share among your friends so that everyone will get benefited out of it. Thank you.